Well, thank you everyone for coming to this session. It's great to see a full room. Intimidating, but great. And so I'm David Atkins. I'm a solution architect with Progress, and I'm going to be speaking for about 10 minutes, and then Chris Riddell, who's going to introduce himself later from Strategic Information Technology, is going to talk about his real-world experiences building ABL web handlers. I'm going to put a bit of context around how we evolved to the point of ABL web handlers being our recommended best practice approach to creating REST API layer for your OpenEdge application. And then I'll hand over to Chris to tell you all the experiences, learning lessons that he's got that will hopefully help you. So this is the agenda. I'm going to talk through just the architectural evolution and how we've got to the point of where we are today with web handlers, the web handler, protocol handler being the best practice way of doing REST with OpenEdge. And then talk about how you should deploy that. You have to deploy it in PaaS-OE, but tell you all the other great reasons why PaaS-OE should be your app server tier. And then I'm going to hand over to Chris. So everyone's familiar with this in some way, shape, or form. It's the OERA. It's just the tiered architecture. We've been talking about this for I don't know how long. Actually, before I joined Progress about 11 years ago. So separation of concerns, separate your UI and your business logic, essentially, but separate data access and business logic. And we always talked about this in terms of just giving you more UI agility. If you separate it, then your UI can evolve better. You can decouple things. And that's all still true. But these days, more and more of our deployments involve clients over the public internet. It's not just internal. You might have done this originally and created Java Open Client to have a Java front end, and it was all nice and secure within your little VPN or your private network. But these days, more and more of the clients, even internal user clients, are coming in through the public internet, through web, sometimes even mobile devices to get at your business applications. And that means we've kind of evolved our best practice architecture to encompass some of the deployment sides as well. Because when you're talking about that cloud-ready architecture, you need to think about security. You've got to have this kind of this router step. You've got to have authentication. You also need to address the fact that the scale is less predictable when you've got clients coming in over the internet. So you've got this kind of clustering layer with a load balancer. There's other things to concern yourself with. But you fundamentally got the same application level separation, database, app server, protocol layer, service interface layer that you've always had before. And because of the variety of modern clients and emerging technologies, all of which are predicated on REST, that REST service interface layer is becoming is the most important one now. You probably still need to support other types of APIs for more legacy clients and backwards compatibility, but REST is the way forward. And in terms of REST best practices, REST service interface best practices, we've had a few different approaches. We've given you a couple of different approaches to implementing REST APIs. And if you've done REST, well, you may have done it way back when, writing your own socket level code. I know a few customers have done that. And they were very happy when they didn't have to maintain that anymore. But then the next iteration with Classic App Server was the REST adapter. It was a Java implemented servlet deployed in Tomcat. It worked, but the tooling to use it was quite inflexible. It didn't give you enough control over the REST URL and everything. And the net result was a very black box solution for a service interface. You couldn't really debug through it and see what was going on. The mapping file used for it was very opaque. You couldn't really understand how the REST request coming in was going to map to the back end unless you were the one that created it in the first place. So when we released PaaS-OE back in 11.6.3, we introduced the web handler protocol as a new way to do REST and handle REST. And it's really our best practice approach. But there's three ways you can use that web handler protocol. If you want the quickest, highest productivity way to do it with least control over your REST API, meaning least control over the URL schema, you don't control what headers are supported, what query string parameters, then you can do a data object service. This is kind of like those JSDO services, if you've heard that term, where you just create a business entity, add it to an ABL, it will generate a JSON catalog describing that, and you have a REST service. It's very prescriptive, but it's quick, and it has the advantage of integrating with a few UI tools. Things like Kendo UI Builder, Convey Native Script can look at that catalog and understand the interface to that service, and you get some productivity benefits. But for the wider world of REST, where you want to create exactly the REST API you want, as with the open banking platform that Chris is going to talk about, You have two approaches to creating custom REST APIs where you define that URL schema and supported headers, query string parameters. What we're going to talk about mostly here today is the ABL WebHandler or do-it-yourself WebHandler where you code the mapping between the REST world and the ABL world yourself in a WebHandler class. I'm not going to go into a ton of detail on that because Chris can talk about that. We have another approach which is essentially a pre-built web handler that we've created that will read its mapping from REST to ABL world from a JSON configuration file, and that's called the data object handler. And that's a good approach if you want a non-ABL person to be able to craft some of these REST APIs. If you're very constrained on the ABL resources front, data object handler is an option. It's a particularly good option if your back end is already nicely separated and you've got service interface classes, procedures that you can call. Web handler is a better approach if you have ABL resources, you want to have control, and you want to have the ultimate in the ability to debug through exactly how that REST interface, that service interface layer is operating. And if you're going to have to refactor some of the back and put wrapper classes and everything in place as part of this process, then the web handler is the way to go. And all three of these are using the same web protocol, or web protocol handler. So just to give a little bit of insight into that in general, if you have a REST request coming into PAS-OE, you got the full URL host name and then web app. If anything after that is /web, that basically says use the web handler protocol to handle this request. And the first thing that does is it triggers a lookup in the OpenEdge.properties file. So now PAS-OE has an OpenEdge properties file for each PAS-OE instance. There used to be like a shared ubroker properties for all of those classic brokers, but now you have one of these OpenEdge.properties files for each PAS-OE instance. And that has a list of lines like this one. So handler 1, a particular class name for a web handler class, and then a URL pattern. So once it knows it's web, it goes, looks in that file, finds the appropriate web handler, instantiates this class, and basically passes the entire HTTP request to it. So this class can then look at the body, it can look at the HTTP headers, it can pull out path parameters that are passed in, query string parameters, it's got access to everything. And likewise on the response, it can set everything. You can set the status. We're doing read talks here. Maybe you're reading talks, you put the talk information in the body, but maybe you also want to put a count of how many are returned as a header value in the HTTP response. You can do anything you want to in the implementation of your web handler class. That's the basic mechanics of how it operates. And this is only available, this web handler class, with PAS-OE. And I'm sure everyone is in the process of either moving to PAS-OE or figuring out when are we going to move to PAS-OE from Classic. And don't think of it, please, as a chore that you have to because Classic's not in 12. Because this web handler, if you're going to do REST, this web handler is a better way to do REST. So moving to PAS-OE, that's one good reason. But we talked about scalability security as being really, becoming more and more important in modern architectures. And those are much, much more superior in PAS-OE. It has Spring Security. It doesn't just have Spring Security. It has Spring Security with an abstraction layer on it with properties files instead of having to edit Spring XML, which is a pain. Scalability, it's got the multi-session agent. It scales better, but it's also just a standard HTTP app server. So you can load balance it, cluster it much more easily than you could with the old Classic app server. Simplified architecture, much more options for managing, monitoring, administering it. This is what we're talking about. Flexibility with REST is that you have that web handler protocol. Supports containerization. We've already put out releases, container Docker images for PAS-OE, and you've probably seen some of the presentations this week about that. And it's not only is it go forward, meaning it's the only app server in 12, but all of our future innovation on the app server tier will be in PAS-OE. So there's got to be enough reasons here to make you excited about moving to PAS-OE, I hope. Okay, and with that, I'm going to hand over to Chris, make sure he's got enough time to talk through his slides.
Thanks, David. Good morning, everyone. I'm Chris Riddell. I've been an OpenEdge developer for almost 10 years now, and more recently I've been on the software architecture side, and I've been the principal architect for the Plus Open Banking, or David mentioned our open banking platform, and that's what I'm going to talk to you a bit about today. I work for a company called Strategic Information Technology. We write banking software. We build financial solutions software. We've been a Progress partner since 1988. And we've got clients across Canada, the Caribbean, the UK, and in Ireland. We're about 125 people and about 40 OpenEdge developers there. And today what I want to talk about is our actual experience building a RESTful API in PaaS-OE. So I'm going to go through some of the background of what we've been up to, the architecture that we use with our application, some of the development stuff that we've done around the ABL WebHandlers, how we documented it, and some of our continuous integration delivery pipeline that we use, and then some conclusions about the project and where we're going to go from here. And I'm going to try to kind of cover a lot of ground with this, so it's going to stay pretty high level, but hopefully it helps give you guys some ideas and some of our actual experiences, some of the challenges we've gone through, and hopefully that's going to help some of you as you're getting started. So for some background, where we started, so we have a legacy application called Portfolio Plus, and it's a feature-rich core banking solution. We've been building this since 1988, so that's 30 years of functionality we've been putting in this product. But it's this monolithic application, it's a thick client, and it's tightly bound, right? Business logic to ABL UI to data access and typical kind of legacy application. The only way you can use it and the only way to get at all of that powerful functionality today is through the ABL UI, which is just outdated. And we've been on this modernization journey for a little while. And that's the main challenge with this. So our primary goals with this project were to create an open banking capability, to build an industry standard RESTful API into this powerful backend. We want to enable ourselves to build new user experiences and user interfaces, more modern web-based and mobile applications, but to allow our customers to do these things as well. We've been moving towards a more agile development methodology, trying to speed up how quickly we can get to market with these things, trying to enable more automated testing and deployments, and working towards CI/CD. And the main goal of the application itself is to move to more of a thin client model. The legacy application tends to be really chatty with the database. So there's a lot of performance challenges around that. And if we move to this type of model, all of that chattiness gets replaced with a few HTTP requests, right? Pulling back higher level data sets and making it a more efficient application. And this is going to help enable some of our future business strategy to move to get these new applications and new user experiences out more rapidly than we're capable of today, and to empower our clients to build their own applications. More and more, especially our larger clients who've got their own development shops and lots of resources, they want to build this stuff themselves. They don't want to wait for us to come out with this. And we're finding, clients are starting to look towards other vendors that can do this for them. But we've got all this powerful technology and we want to make it available to them. We want to be able to take advantage of new technologies that come out. And chatbots are a good example today, but who knows what's going to be next, and we need to be able to move on those new technologies and adopt new technologies, and we just can't do that with the legacy application. And we've been working hard to build an API-first development culture, meaning that legacy application, we're building lots of monolithic procedures, and they do that and they can't be reused for other UIs, even ones that do similar things. So it's been really important for us to move towards API first. And I think it's important to say that even though I'm talking about web handlers and a web API first doesn't have to mean that. You can write procedural ABL APIs into your backend logic, but the key is to separate that backend logic from the UI, and then you'll enable yourselves to make a web API on top of that, or whatever else you need to do. So if you're not at the point in the journey that we are and needing a RESTful web-based API, you can still adopt an API-first culture without going that far. And I think that that's important. So I'll talk a little bit about high-level architecture of our application, just to give you an idea of what we've done. So the diagram there, that came out a bit smaller than I hoped. What we ended up with was a multi-layered API. So the top layer of, and I should say each one of the boxes there is a PaaS-OE instance. Inside each PaaS-OE instance are two web applications. One of them is the actual API that runs all the business logic behind the RESTful API, and the second is an authentication app. And that one gets used to authenticate that users are who they say they are and return tokens and do all that good stuff. They're separate web applications so that they can be deployed separately if we want to. It's drawn this way because typically today we deploy both web apps in one PaaS-OE instance, but we could easily separate them, deploy them to different instances, different servers, whatever we need to do. So the top layer there that I've called function-specific API layer is a set of APIs that are there to enable certain parts of the business. So the one that we've built for this project is the consumer banking API. So it's exposing a subset of the overall functionality, and it's performing authentication and authorization of consumer banking users, where a consumer would be you or me, accessing our banking information through a web app or through our mobile devices. So this one is there specifically to authenticate those types of users. And in the future, I imagine this pattern expanding to other types of users for other types of specific apps. It's nice because it moves all of that complex authorization logic out to this level where we can manage it there. And if we need to make a new app with new authorization rules, that's all it'll do. And that makes it fast to build and easy to build. And the middle layer is the core business-to-business API, which does all of the heavy lifting. All of the actual business functionality, the business logic is there. All the data access happens there. But because we've moved all that authorization code out, it can stay nice and generic, and all that other complicated stuff happens somewhere else. And I just threw the database in the diagram because I think it's important to say this is the legacy database. We haven't touched it. This is the same database that gets used by the legacy application, the same data model. We didn't have to do anything there. So that's been really nice. So I mentioned authentication. So just at a high level from a security perspective, we're using OAuth 2. Support for that comes available with PaaS-OE out of the box using the Spring Security Framework. I'm not going to get too deep into OAuth in this talk, but we use a few different parts of it that you can read more about. But the client credentials flow for the business-to-business API. So if I just back up a little, the consumer banking API is a client, right? That's a client application for the core business-to-business API, so it authenticates itself, just like a user. And then we also use the resource owner password flow for any client applications connecting to the consumer banking API. So in that case, the resource owner, again, would be you or I. We own the resources we're trying to access, right? And part of the authorization step there is to validate that that's true, that you are asking to do something against a resource that you own, like your own bank account. And like I said, we do the authentications through a separate web app deployed alongside the API web application. And you could deploy it separately if you wanted. We deploy them together. And then I put together just a quick animation of sort of how all this flows. So you've got the consumer API on the left, making requests and authenticating itself against the core business API on the right. So the first step has the consumer API's web application. So some users made a request to the consumer API for some resource, say their banking history. The first thing is to request an OAuth 2 token from the authentication app on the B2B side. So we send a basic auth request. The B2B side does the validation. Yes, I know this client and I trust them, and returns a token. So what I've shown here is sort of a snippet of a JSON response that comes back, and it's got an actual JSON web token embedded within it. I didn't actually write it out here because it's really long and unreadable and doesn't mean anything anyway. So where the JSON web token is there, you get that long JWT or JSON web token, and you can read more about those. Now that the consumer API has this token, it's going to add it to every subsequent request that it makes. And now it's talking to the core API's business logic web application. So you can see at the bottom of the request, we've got the authorization header with the bearer token. And now that goes back and forth. The B2B side just validates that, yes, that's a good token, and then returns data. And so that's sort of a simplified flow that's how we're managing authorization or authentication tokens. So with all that in mind, I'm going to talk a little bit more about the development that we did, specifically around web handlers, and some of the, hopefully touch on some of the challenges that we've had that I think you might run into, and what's worked and what hasn't. So first, why did we choose ABL WebHandler? So like David was talking about, it was important to us to have full control over the URLs. We wanted to make a RESTful API that was going to follow standards and be nice to work with. And so the annotated REST and the data services, data object services didn't quite work for us. So it came down to choosing one of the different web handler options. So I gave a few examples of what kind of our URL stubs look like. And it was really important to us to make it clear that this is the exact resource that you're asking for. We wanted to have control over the parameters that get passed in the URL to represent what those resources are and to identify them. So in order to do that, web handlers made sense. It's also really nice that you get the entire HTTP request. Again, like David was talking about, when you instantiate a web handler, when it gets run, all of the information gets passed in an iWeb request object instance. And everything's available there, from the request body to the URL parameters, path parameters, query parameters, headers, and we're able to use all of that information on the web handler side. So that's been really nice. Actually really easy to work with too. And there's lots of good documentation about that. We did consider the data object handler as well. The two main reasons, I guess, that we didn't choose to go that route. One, we were refactoring and rewriting a lot of code anyway. I imagine if you're someone, or if you're with an organization coming from like the classic app server, and you've got a bunch of procedures that already exist in a sort of headless environment, you could just reuse. The data object handler might be really good. Also, we're an ABL shop. Our developers understand ABL, so we wanted to be able to get in there and write the code. And that's kind of where the decision ends up being, right? Do you want to write the code yourself and directly use ABL web handlers, or do you want to let the data object handler do it and just write JSON configuration? I think both are good choices, but that's kind of why we ended up with this. And it's important for us, these web handlers that we wrote they're just an HTTP service layer. They do very little work themselves. They're all really small classes. And it was key that we could write them that way. Because now in the future, if we need to support some new communication protocol, even if we needed to put a version of this together that used SOAP instead of REST, maybe for a specific client, specific application, or whatever the case may be, we're just going to have to write that layer, and it can call all of the code that the web handlers call today. So it's important that it was a specific service layer here. So that leads into what's in these things. So what we did was wrote one kind of core implementation of the web handler. And so all of our requests flow through this. So it's just a class that does a lot of common processing, right? And then all of our specific handlers, and there's lots of them, basically for every URL resource or business process that we expose through the API, there's a web handler for that. And those all inherit this common one that we wrote. And that let us do things like make a database connection, pull information out of the client principal, do common logging, take common logging steps, such as logging that this is the API that was called, what were the payloads for debugging, and that all goes in one place. So if there's any common logic that you want to run anytime you have any request come in, this is the place to do it, and that's why we did it that way. And like I said, the web handlers, for the most part, we were refactoring and rewriting code because most of our functionality in the legacy app is tightly bound to the UI. And we couldn't reuse anything with ABL UI in it. We can't reuse those procedures here. So we're refactoring and rewriting those. And we were defining object-oriented patterns for those. We followed the OpenEdge reference architecture for the most part. And actually, a cool thing that you can do with Eclipse, with PDS, is define snippets of code in templates. So we did a lot of that. So we would come up with a pattern. This is what I want WebHandler code to look like. This is what I want data access code to look like. And we define them in these templates and push them out to developers. And just with a few keystrokes, you can generate an entire class. And that was really handy. I'd recommend looking into that. But in a lot of cases, we could, sorry, not a lot of cases, but in some cases, we could still use the existing business logic. We have background processing, some of the really complex transaction posting for like retail accounts or loans. That stuff was a little bit more headless because it runs in a different way, not directly in the UI. And so in cases where we had code like that, we can still reuse it. So again, if you're coming from a classic app server world, or if you have more background processing, you can absolutely reuse all of that. You can call procedures from your classes. You don't have to rewrite. Yes?
Yeah, did you see any issues with the complicated legacy logic running for several seconds, or APIs?
Yes, in some cases. It sort of, for us, came down to, we'd love to refactor everything and improve all that performance, but timelines being what they are, right, we had to reuse them. So yes, that's true, and you have to work around that sometimes. But the biggest challenge we had with this were all those procedures that use shared variables. So shared variables, shared temp tables, that's common in our legacy logic. And normally it's the UI components, I guess, that are defining those. And you can't define shared variables in classes. So in a lot of those cases, what we ended up doing was just writing little wrapper procedures. Their entire purpose was to create shared variables and call the actual procedure. And then we can call the wrappers from our classes, and that's how we got around that. But that was definitely an issue. And another good decision that we made while we were developing this was to use pro data sets for all of our data access. So the entire data access architecture is built around pro data sets and temp tables. This means that we can kind of fetch all of our data up front in a process, put it in this pro data set, perform all the business logic, all the validation, now on this temp table in memory. So we're not constantly going out, and we don't have such a chatty application with the database, which is really good for performance. This means all of our database transactions are also short. So in our newer, updated, refactored logic, we do all the work on the temp table, and at the end of a process, we're writing it back to the database. So we don't have transaction scoping issues anymore. We don't have to worry about exclusive locks held for a long time. And it just solves a lot of those problems. And this also means all of our database queries are dynamic. Most of them happen under the covers through the pro data sets. There's the odd case where we have the need to run an ad hoc request. And we've made a rule that all database queries have to be written dynamically. But what this lets us do is compile the code without a database connection. So all of our code gets compiled on our CI/CD pipeline, and we can deliver that anywhere. And we deliver with this application only prolib files. We don't deliver, Xcoded source anymore. We don't deliver just our code. We don't compile at client sites. And that's enabled, or helped to enable the continuous integration pipeline. But the biggest challenge with this and with accessing data this way, and I think personally that this is the biggest challenge with the whole project and with the whole modernization journey, is that this is very different from what our developers do today. And I bet that's true for a lot of you, maybe all of you. So training people to think differently, to embrace doing things this way is a big challenge. And I think it just has to be done. And all you can do is define good patterns for them to use, train them on why that's good, and support them while they're trying to figure it out. But what worked well for us too, once we had these patterns defined, we tend to sit down as a large group, or large-ish group, in a workshop sort of a setting. So if I'm running the workshop, I'll actually take a business requirement, sit at the front of a room with a projector, and code it. And we'll all take one requirement and we all code them together, and we work together. We talk out why we're doing it the way we're doing it and talk out the issues we're having. And that's been really effective for us. So if you've got a few people that are kind of leading these sorts of things, or these sorts of changes, I found the workshop worked really well for this. And the last thing around web handlers to talk about is deployment of those, and David did touch on this as well. You define these in the OpenEdge properties file that you deploy with PAS-OE. And basically, it it's a big long list. For us, it's a big long list of web handlers and URLs that map to those web handlers. But the sorting of those is important. If you've got URLs, and we do, right, that look similar to each other, maybe you've got sort of a parent resource with a bunch of different child resources, you have to get the order of the definitions correct. Because what PASOE does is it takes the URL from the request, it looks through the list of web handlers and finds the very first one that matches that. If you have your parent resource defined above your child resource, it's going to choose the parent. And those can be challenging to debug. So it's important to get it right. And when we had 5 or 10 of these, so the challenge around this was that we were managing that configuration manually at first. We didn't really look at what the tools made available for us. And this seemed fine when there were 5 or 10 web handlers, but now that we have 130 or so, adding a new one, figuring out where it belongs in that list, renumbering everything, it's unmanageable. But we ended up using PDS and the defined ABL services there, and that worked really well. And we just had to kind of create a naming convention to help make sure they got sorted properly. But now it's part of our build process to generate that OpenEdge properties file. We don't maintain it ourselves anymore. And it's really easy. So I would encourage you, look at the tools, look what they can do for you, and try to plan that stuff ahead. This one set us back at some point.
So you have a var file for every one of the 130?
No, sorry. We have one war file per application. For every one of the 130 web handlers, there's one entry in the OpenEdge properties file. The idea is it's mapping this URL. That's the web handler that runs the business logic behind that URL. But we build the war file automatically. The OpenEdge properties file that we generate it's a Delta file. And when we do a deployment, there's a utility called OEprop. And that lets you take that Delta file that the tool generated and merge it in at deployment time. So that's kind of how we do that. But it was important to let the tool manage this sort of stuff.
Web handlers do not create a catalog file. You cannot use them with PDS.
Right, they don't. Okay. So I'm going to talk a little bit about API documentation. So that was our development journey. Hopefully, hearing some of that helps some of you if you're starting yours. But another important piece for us was documenting this. We want our clients we're trying to empower our clients to create their own applications with all of this. Well, they need to understand what's in there, right? So it was important for us to come up with an industry standard specification that those clients could use and use their own tools with. So we chose OpenAPI or Swagger. And this is becoming bigger and bigger in the industry. Everything you read, everyone's using this now, and it's really become the industry standard. So it was important for us to do this. We used some of the Swagger tools, Swagger Editor in particular, and that lets us develop the specification and test it interactively. So that's really good. But because it is industry standard, there are lots of tools out there. Our clients could use whatever tool they want. They don't have to be married to Swagger. But this also lets us collaborate with third parties, which was great. So as part of the Plus Open Banking platform, we were building new web and mobile applications. So our Plus Banking is our web offering, and our Plus Mobile is our mobile offering. And we partnered with Servoy on those. Our development shop is really ABL oriented. We have a few people that write JavaScript and HTML, but not so many. And that's been part of our challenge too, is finding people that can do that or training people to do that. And we brought Servoy in for this one, and they helped write the application, and at the same time trained our developers how to use their tools, and how we're going to move forward in the future. But it was really helpful having them just read the specification and help build the app. And Progress, David actually was able to build a really simple chatbot. It starts new loan applications. But it was really cool because last year we were going down to Pug Challenge in Massachusetts. And we had spoken a little bit about this project, and we gave him the specification. And within a week, less than a week, I go down to Pug and he shows me a chatbot. And for me, it was really cool because that was validation that we were doing the right thing, right? We had this specification, we had this API up and running, we deployed it to AWS so he could use it. And a few days later, there was a working application with almost no input from me. And that was just this really awesome little validation that we were on the right track. It was really cool. But the biggest challenge we found with the documentation for ourselves is that we did it too late in the process. So we would take a business requirement, hand it to our developers, and they'd go work. And one of the artifacts that came out of development was the specification for whatever APIs they created to support the business requirement. But that was not so good for us because we're trying to be agile, but that got us into these little sort of waterfall modes, right? Where no testing could happen and nobody could build anything on the front end until the developer was completely finished what they were doing, because what they were doing was building the spec. So I would encourage you, and what we're going to do moving forward is define the spec up front. We'll take a business requirement, decide what APIs we need, and if we're building new ones, we'll define the specification up front, hand that to the developers, and they won't start coding until they get it. And at that point, the specification is the contract between the developers and everyone else. So testing can start right away, or at least we could start developing test scripts. We could start developing a front end immediately, knowing what the inputs and outputs to that API are going to look like. And we want to move in that direction towards more of a test-driven development model, where by the time development's done, we can just run the test and prove that it was right. So that was a big challenge, though, for us. So having said all that, I'm actually going to show you a quick demo of Swagger and what we do with it. So I'm just going to change this. So this is Swagger UI. I talked a little bit about Swagger Editor. They're slightly different tools. They do really similar things. But it's ingesting the specification file. You can actually see it in the bar here at the top. We use YAML. You can use JSON schema as well. I find YAML a little bit easier to read. And so this tool reads that in and makes all the documentation defined there available through this neat little UI. So if I scroll through it, at the top, you can enter some server information, and this is where the API is running, where the PASOE application actually is. And you can create sections of related APIs. So that's what these all are, and you can add all kinds of documentation into this to explain what these sections are for, what APIs you're going to find here. But if I scroll down, I'm going to show you our client profile API. And within this, you can define, again, all kinds of documentation to say this is what the API is, these are the parameters and what those are for, and this is an example of a response that you'll get back from this. And you can customize those or not, whatever you want to do. And then what you can do with this, if we click the try it out button, is actually send a request. So you can see, if I do that again, the client number parameter, which is, you can see up here as part of our URL, turns into a box that I can fill in. So if I enter some information in there and click execute, that actually sent a request to the running API. This shows you what that request exactly looked like. And here we get a response. So this one failed. We got a 401 authentication error because I didn't authenticate myself. So the other thing the tool lets you do is go through your authentication process. So if I click this little lock icon, you can see all the available authentication methods here. And like I mentioned earlier, we use OAuth 2 and client credentials. So I've scrolled to the bottom, fill in my credentials, authorize. That's actually sending a request to the authorization web app I talked about and getting back a JSON web token. So now we have one of those. And if I go re-execute this request, you can see the difference in the request, and it's got that bearer token. So that's that long unreadable string I left out of my slides earlier. And that's the JSON web token. So that got sent with the request, and now we got data back from this API. So this is what we use Swagger for. This is why we use it. It's interactive and makes it easy to test these things. So I'm just going to fix this and jump back to my presentation. It's taking a second. Okay, sorry. So back to the presentation. So that was Swagger, but like I said, it's an industry standard spec, and there are lots of tools available. So this is actually a tool called Redoc, and we've been working internally on some more like business analyst-friendly versions of the documentation. So I just wanted to show it as a quick example that you can take those industry standard specs, plug them into different tools, and easily generate different types of documentation. So now I'm just going to talk a little bit about our CI/CD pipeline. I'm going to kind of glaze over this slide. It's just a list of the tools that we use, what we use them for, and you can check them out in the slide deck and look into them if you want to, or come ask me more about them. But what I want to talk about is what we actually do with these pipelines and what's important for us. So the biggest one, and earlier on when we were starting these projects, it was really important that we automate the compiles, not just compiles, but every time we check in code now, we've got a Jenkins job that runs, it compiles the code, creates a PL file, runs all the unit tests that we've been defining. We actually have an installation of SonarQube now, so we run linting against the code, and we can make sure that developers are following the patterns, which kind of takes some of the load off doing it through code review. And we get to see code coverage, so I know how much of the software is covered by those tests that ran. So this is the biggest one for me, being able to automate all of that. So now if I checked in code and broke a compile or caused a dependency upstream to no longer compile because I changed a method signature in a class, I find out really quickly, and it's a lot easier to fix. After we've built PL files or WAR files or whatever deployable artifact comes out of the build pipeline, we push it up to a repository. We use Apache Archiver for this. But that repository just holds all of our deployable artifacts. So later on, when we're able to deploy these automatically, we just go download them from there and we're good to go. You don't have to wait for a build. It's already been done. And more recently, we're getting into Jenkins pipelines that are capable of creating new VMs and deploying our legacy application, our databases, and our new PASO-E applications to those VMs for use by our developers, our testers, for demos or whatever. So we're still learning on that one, but this is where we're going with the CI/CD pipelines, and it's why those early steps and the compiles are important. It enables all of this stuff. So where are we now? We've been working for about 8 to 10 months on this open banking platform project, and we've converted about 200, it might be closer to 230 of our system resources or business processes into RESTful API endpoints that can be used by other applications. We have been successful in refactoring this and making unit testable components. So our automated testing runs about 1,000 unit tests for every commit. So we're constantly testing the application. And I feel really good about that because I can honestly say to people that we're building a better quality product and I can prove it. And I can show you that I'm testing it and it's good. And changes that we make are good and they're not breaking anything that was already there. We've finished our first versions of our Plus Banking and Plus Mobile applications. They fully utilize the REST API. And like I said, we were able to do that with Servoy, helping as a third party. And even some components of our legacy application are calling these APIs now. So that's a longer term project. There's a lot there, but I would love to transform it to be another API client and a thin client. And we're getting there. And so where are we going to go in the future? We're expanding on those application API layers. We're going to expand the authorization capabilities. Like that architecture diagram I showed you, we're going to follow that pattern and have more kind of application-specific APIs and keep building that out. We're going to keep working towards our test-driven development, like I mentioned, writing the specifications earlier to enable us to do that kind of thing. Continuous deployment is big. We're going to start looking, hopefully in the near future, at these PASO-E Docker containers. And I think that's going to be really good for making repeatable deployments. And we can make sure that the exact application we tested is the exact application a client's going to get. Right now, the biggest problem we have with that is there's a lot of in-house scripting. There's a lot of moving parts with our deployments. It's going to be really easy to make it different by accident. And we want to, from a business perspective, expand our market. We don't want to just be selling the legacy application to clients that need that thing. We want to sell the open banking platform, the API to anybody that wants to build an application and needs core banking functionality. And it should open up and expand our client base, as well as meet needs for existing clients, like I said, that want to build those applications themselves. So that's where we're going with this. So that's been our journey. My email address is on here. I'm totally open to questions, or if you just want to chat about where you're at and what we did. Yeah.
So you have a legacy app.
Yep.
And you have this RESTful app. Now you have shared code between the legacy app.
A little bit. Yeah.
So in your continuous integration, I'm assuming that your maintenance or your modifications in your legacy app haven't stopped.
No, that's true.
And so how do you deal with that?
Well, we have automated compiles now for the legacy application as well. There are fewer unit tests with that. It's harder to do. But we're relying on the unit tests for the REST APIs that actually call into that legacy functionality to guarantee that it's still working. So if somebody adds a new feature, we'll find out when we run the RESTful API tests, right, if it broke or not. Yeah.
Are you testing with unit tests? Are you testing the REST APIs?
Sorry, so no, we're testing all the business logic behind them.
You will test this because then you could change it out. REST is gone. You could change it out and out
Right.
later and still have to change unit tests.
Yeah. So we have tests for every new class that we create in the business logic and the data access behind the RESTful APIs. Sorry, I said that wrong, but we use Selenium on the front end, so we are testing the front end applications, which are testing the REST APIs, and we're starting to look, and this comes back to the test-driven development, and we're starting to look for tools now that will allow us to test the REST APIs. I've been talking to some of the Progress folks here this week about Test Studio, but we use SOAP UI a little bit. We've tried a few different tools, and we do also test that. So we're trying to test every level of the application.
Can you give an example of, a test, what's the expected result?
That is kind of a vague question, right? It totally depends on which part of the process we're testing. If I'm testing a data access procedure, then I'm testing that at the end of it, that the pro data set I get back has the data I expected in it. I might be testing the actual API itself, in which case I have an expected JSON request or response body that's going to come back. I'm trying to validate that that's exactly what I got. So
So you have like a JSON document that
Right.
is your expected result.
Yeah.
And you
Yep, that's pretty much exactly what we do. I saw another hand. Yes.
You mentioned you didn't use JSDOs, so did you roll your own server-side paging and searching and
So
filtering?
yes. And that's something we're still working on and trying to evolve and improve, but yes. Any other questions? Okay, well, thanks for listening to me.